So finally, I say, in reference to the slogan of the now late, great Sun Microsystems, which coined the phrase, "The network is the computer," and I'll say the network is the cloud. The cloud computing was essentially sort of named for the metaphor of being able to use resources that are out in the cloud. When people draw networks, they draw the cloud. The internet is the big cloud, and so that's there's a strong interplay between using distributed resources and the network on which those resources are connected via. So I believe that dynamic networks, the ability to allocate the network alongside computing and storage, is the missing piece of the cloud computing picture. I think there's a lot of work to be done, but it's a very exciting time in terms of the technologies and advances that we're seeing as researchers and enterprises together are all moving toward the technology that cloud computing technology, very much changing the face of computing. The last observation and sort of the key to my day job, the work that I do, is that performance in this case doesn't really just happen. We can't just assume distributing things around will be without performance impacts. There are various tools that we have, various approaches, many things that can be done, and these have to be applied. This needs to be a first-class consideration when applications or services are ported to the cloud. So that is what I have. I don't know if we have time for questions or comments, anything. And it turns out I was muted the whole time. Oh, no. I'll start over.
And he has already defined half a dozen new PhD topics, but maybe he'll give you a few more if you ask him some questions.
UCLA has a question.
Yeah, the question is that isn't there a single point of failure in the software-based virtualization, like in the VLAN? The OpenStack Nova, the master node which controls the VLAN, if it goes down, won't it bring down the entire VLAN network for the cloud images?
Well, so generally, you can think of one thing that we say in networking is talk about in networking is the distinction between the control plane and the data plane. So what the controller does is really establish the rules and establish the configuration of the network, but then generally the data plane is distinct. So in the case of, for instance, software-defined networking, decisions are made about a flow or about a virtual LAN or about a connectivity by the controller, by a bit of software that then pushes that into the hardware. So if the software fails, then for the most part, with some exceptions, the hardware will continue to perform as it's been instructed to do until the software comes back. I mean, that's a great question. And in fact, there was a session 2 nights ago here that was very exciting, very spirited debate about software-defined networking. And one concern raised repeatedly, actually, was exactly what you just highlighted, which is, do these software controllers become a single point of failure? So in practice, I can say that companies that deploy software-defined networking, little guys that you may have heard of, like Google, deploying software-defined networking, they have a series of parallel controllers for failover, and these controllers are kept synchronized, just like Google does with its other infrastructure. And Google's not the only one doing this, of course. Other commercial companies have parallel controllers, synchronized state, to address the inevitability of some software falling over and having something else step in to take its place. So again, and that's also an interesting application of cloud-type ideas, in that as the demand on a given controller grows, you can add more nodes to the virtual controller pool, for instance. But that's a good question, something to keep in mind in system design, but certainly there are techniques to mitigate it.
Thanks.
you very much, Martin.
Well, thanks very much, everyone. Pleasure to be here.